Life has problems, let's find solutions. Alright, this is determining the number of significant figures in a number. And so this video is going to show you how to tell how many sig figs are in a number, and we'll also tell you a little bit about the reasons why. So I think it's important, if you're going to understand what significant figures are, like how they work, I can show you a bunch of tricks on how to just count how many sig figs are in a number. But if you don't actually have an understanding of what a significant figure is, why some figures are significant, some aren't, I don't think that really helps you as much. Let's say, for example, we have the number 10. There's the number 10. But also, here's the number 10. And also, here could be the number 10. Here's also the number 10. These are all the same value, but if they are measurements, they are actually reporting to you a different amount of information. They're letting you know how precise the measurement actually was made. The one that is just here on the left actually only has one sig fig, and it wasn't a very precise measurement. The one over here all the way to the right, there's a lot of precision in this measurement, and we knew not only was it 10, but it was very exactly 10. This is the concept of significant figures. It's all about being honest with how well you actually know that number. And depending upon how many digits your number ends up having in your measurement, you are reporting how well you know that measurement. Let's do a little bit of practice here. Let's say I've got a screw and I'm trying to measure its length. I really need to know exactly how long it is to the best of my ability. And this is the kind of ruler I'm using. This could be whatever units, inches, centimeters, doesn't matter. Let's just call it centimeters. And if I were to make a measurement with this, I've got it lined up with the 0, and I can see that it doesn't quite make it to the 3. And so I know it's 2 something. It's definitely past the 2. So I know for sure that the measured value is going to be at least 2, but it's not going to be 3. Now after that, I don't exactly know where in between that 2 and 3 it is. I've got some idea, and so I can estimate the tenths place. I could say it's 2 point something, and I'm going to just eyeball it here, but I think if half is right here, it's past the half, so it's definitely above 2.5. I could maybe call this 2.7. So 2.7 centimeters. Now somebody else might look at that screw and they might say that it was 2.8. Somebody else might say it's 2.6. Somebody else might just go crazy and call it 2.4. Whoa, that's crazy. But still, that last digit here in the measurement, this is the one that we have some uncertainty about. I know for sure, I am absolutely certain it's above 2 centimeters. Assuming my ruler is correctly made, I know that I've got at least 2 centimeters here, but this 7 is the one that we were uncertain about. When we report measured values, the last number, the last significant figure, is the one that there is some uncertainty about. Alright, so maybe I'm not satisfied with that ruler, so I go out and I get this more precise ruler that actually measures out not just the centimeters, but it measures out the tenths places too. Now I can get a more accurate reading on this. So again, hey, sorry about the lines, I didn't draw them perfectly, but pretending that that's okay, let's say it lines right up to, well, right about there. And if I count over now, we're past the 2.5, here's 2 1/6. 2 1/7. It's like right at the 2 7. Hey, I eyeballed that pretty correctly, huh? Helps when you're drawing your own lines on your ruler. So I could now say it's 2 point, and I see that, yep, it does line up with the 7. And so now I do know that number, and the way I've drawn it, it actually lines up with that 7 tenths of a centimeter almost perfectly. So I could say even, it might be if I zoomed in with like a microscope, maybe it's a little bit past it, maybe it's a little bit earlier, but I'm going to estimate, and I'm going to say that it's 2.70. It's right on that 2.7 line. So I can then go one more place further and call it 2.70 centimeters. I know for sure about the 2. I also have very good certainty about the 7. It's this 0 that is potentially estimated and thus in question. This number has 3 significant figures, whereas the previous one only had 2. With more information on my measuring instrument, I have more information on my measurement. Now again, somebody else might have estimated that and called it 2.71, or somebody might have said it doesn't make it to the 2.7 line and call it 2.69. The point is, though, we know the first 2 digits in this measurement very well. It's the third one that we have some uncertainty about. Now this idea, it also works for digital equipment too. Let's say, for whatever reason, I'm bored and I want to measure some rocks and see how much they weigh, see what their weight is. So I put my rock on the scale, and on my digital balance, it reads out that it's 16 pounds. Let's say that this digital balance is only able to measure and report the ones place. So it told me that it's 16. Now, what does that mean? It means that I do know for sure that it's over 10 pounds. In fact, I also know that it's over 15 pounds to some degree. But the way a lot of computer programs work inside of these digital readers is they will round the whatever placement they have, whether it tips the scales or not. So in reality, this rock maybe isn't 16 pounds. It might be 15.5 pounds in reality. 15.5 something. Could be 15.5000, and it could be 15.51, 15.52. And if that happened, then the computer readout would take that 0.5 and round it up, so that way this becomes 16. Also, though, it won't round up until it gets to that 5. So this rock actually could be heavier than 16 pounds. It could be 16.4999 and just not have really got that extra mass, that little extra to put it to the 5 and thus round it up. So we could be dealing with a rock that's anywhere between these two masses or equal to these two masses. And our digital balance that only reports to the ones place is only going to report it as a 16. And so, again, significant figures, it's all about being honest with the measurement. When I say the rock is 16 pounds, I don't really know for sure that it's 16 pounds. So I wouldn't want to say 16.000 pounds when I really don't know that that is true. It could have some mass out there in the tenths place, hundredths place that I'm unaware of. So in this case, my 1 is significant, my 6 is also significant, and that 6 is the one that's estimated. Now, let's say I go out and I get an even more precise digital balance. I'm not satisfied with that ones place measurement, and I put the rock on there, and it turns out, oh, yep, it's 16.3 pounds. Now I've got another significant figure there. I've got that 16.3. That tenths place is now significant because I got a more significant balance, more precise balance. So now, in reality, we've narrowed it down more. The rock could be actually 16 point, and since it potentially did not round that up, well, let's go to the lower limit. We could say it's 16.25000. Keep on going to infinity with those zeros. It could be this mass. This is how many pounds it could actually be, and our scale that measures to the tenths place rounded that value up when it reported it because the next digit had a 5 or above the measuring digit that it can report. That 2 got rounded up to a 3. In reality, the rock could be 16.39. 16 point. If it did not round it up, 16.49999. So it could be that value in reality. Those 9s keep on going for infinity. It's somewhere in between there. Notice though we've narrowed it down with a more precise instrument. That's when it comes to significant figures. It's all about being honest with your measurements. Now, it might look after what we've just talked about that just any number that's in a measurement then is significant, and that's not really always true. Let's say we want to measure some really heavy stuff. So we get this huge scale that measures out pounds to the hundreds. So it can report things like 100, 200, 300, but it could never tell you something like 350. It wouldn't be able to do that for you. So another digital scale, and it's going to round everything to the nearest hundreds place. And so we want, something really big on there. Cars, elephants, who knows. Let's say we get this nice blue whale. I have no idea what the actual mass is of a blue whale, but let's just work with me here, guys. So let's say that it measures out to the hundreds place. We put it on the scale, and it calls it 13,600 pounds. Sorry if that's not a realistic number, but we're just going with it here. So with this value, it measures to the hundreds place. That's what it can report to. So this 6 here is the one that we have some uncertainty with. It could be that our whale is 13,550 pounds. That could be true. It could also be that our whale was 13,649 pounds. Could even have lots of 9s after that. So almost tipped the scales to make it the 50 and round that up, but it didn't. So it reported it as 13,600. In a case like this, We know for sure it's above 10,000 pounds. This 1 is very, very significant. This 3 we also are very sure of. We know that it's over 13,000 pounds. This is significant. And this 6 was estimated. It was rounded by the machine, but still, that is significant. The estimated value is also significant. It's these 2 zeros that are not significant figures. These are just placeholders to show you how large of a size we are dealing with in our number. It's not actually something that was measured out. There could really be little hidden numbers here. This could be a 1 and a 4 if we had a more precise scale. Or it could be that this is a 5, a 7, and a 2 if this was a more precise scale. And it works also backwards with smaller numbers. You could have really, really tiny scales, and if I was measuring out just some grams of a substance and I had a really small sample, I might have 0.00042 grams of something, and if I had that, these zeros here would just be telling you how small the number is. It's only the 4 and the 2 that were actually measured out. So now that you have hopefully the concept of what a significant figure is and why some numbers are and some numbers are not significant, let's actually show you how you can easily figure out from just looking at a measurement how many sig figs that measurement has.